Find the derivative of y equals the sine of 4x over 2x plus 1. So y here is a trig function, sine, of an entire expression, which itself is a quotient of 4x over 2x plus 1. That gives you a hint of how to take the derivative. We're going to start with the outermost function, which is the sine. So the derivative y prime, or dy dx, we'll start with the derivative of the sine. The derivative of sine is cosine. We'll leave the entire inside alone, 4x over 2x plus 1. And now we multiply this by the derivative of the inside. Well, the inside of the trig function is itself a quotient. Here it is, and it's a quotient, so the derivative of the inside will involve the quotient rule. We'll start with the derivative of the numerator, that's a 4, times the denominator left alone, 2x plus 1, minus the numerator left alone, 4x, times the derivative of the denominator, that'll be just a 2, and then the entire thing over the denominator squared. And all this is multiplying that cosine. So we have the cosine of 4x over 2x plus 1. And in the square brackets, let's distribute the 4 in here. That will give us 8x plus 4. And we'll multiply these with each other, negative 4x times 2, which is negative 8x, all over the 2x plus 1 squared. We can now combine like terms together in the numerator, and well, the 8x and the negative 8x will cancel, and I'll be left with just a positive 4 over the 2x plus 1 squared. I'm going to write that in front of the trig function. It's customary to have power functions written first, and I will have 4 over the 2x plus 1 quantity squared, and then times the cosine of 4x over 2x plus 1. This can also be rewritten if we want, though that version may be the version that you will leave it as. That cosine's in the numerator, so you can also put it in the numerator with the 4, and then have the entire thing over the denominator, which is 2x plus 1 quantity squared. There's an alternate way to write that. They mean the same thing, of course, so either version is perfectly fine. There's no way to break up that cosine of that quotient of 4x over 2x plus 1. We'll have to leave it the way it is for that trig function. But there's your two different versions for the derivative y prime or dy dx.